Okay, we are now recording. Let me share PyCharm, and let's share Google Chrome. Okay. All right. So this is going to be an interesting lecture because I'm just putting it all together over the last hour. So we're going to see how it goes. We are going to talk about graphics. We are going to talk about Project 3, and I will work through some of that for you. And I've got to remember I've got 3 mice here, and they work different computers, and I've got to remember which is which. And we're going to talk about Homework 6, which, yes, will come out tonight. It's based on Turtle graphics, and we're going to walk through it in the first part of the lecture and give you an idea of what it is, and then I will share it later today. It's going to be different in that gl.umbc.edu does not have a graphical display capability very easily. Okay, you can make one work, but it's kind of a pain. So Homework 6, Project 3, well, we'll get to that in a minute. Homework 6, when I put it out there, you're basically going to run it on your own computer and then submit your results to GL. And Kevin and Mariah are going to grade your code and your results directly rather than executing. For Project 3, you're going to submit an IPython notebook. So let me type that out now. For Project 3, you will submit the file project3.ipynb to the directory Project 3. Okay, that's how it'll work. It's the normal submit CMSC 201, et cetera, et cetera. Your file is not called project3.py, it's called project3.ipynb because it's a Jupyter notebook, or formerly what used to be called an IPython notebook. It does not have the py ending. How it will work is I grade them. I will download, when you submit your Project 3, I will download it from GL to a computer that I set up a virtual machine on, because I don't worry that any of you will intentionally give me some malware to try to infect my computer, but I do worry that somebody has used a module that has something infected. So I run your program on a clean virtual machine. I grade it, and then when I'm done, I wipe that machine completely. So in case somebody did unintentionally include something, we don't infect anything else. Which is why I grade it rather than Kevin and Mariah. I don't ask them to download student code onto their machines. Like I said, one of these days, hopefully GL will run graphical things nicely, but that's not going to be for a while. So let's talk about Homework 6. There is a simple, this is all in the write-out that I will share. Like I said, it's mostly written up now. There is something called Turtle graphics that was written a long time ago, long before I started programming, in a language called Logo. And since then, it seems like every language that implements graphics of any kind has Turtle graphics as one of its first things. Now, let's suppose that you have, conceptually what you're doing is you have a blank screen that you want to draw graphics on. What you have is at the center of your screen an XY axis, and that's the origin. That's the point x equals 0, y equals 0 in the middle of your screen. And you have a turtle. And the turtle is going to crawl backwards and forwards and in some other predefined ways, leaving a trail that is a line. And by giving commands to this turtle to say move forward, move backward, move whatever, you're going to draw things on the screen. that is basically the idea of turtle graphics. It's a fairly simple graphical way to get things so you don't have to draw triangles using dollar signs and ampersands in ASCII again. So let's see how it works. Okay. The first thing you do is you just import the module. There's a full Python module which should be available to all of you. So you just have a statement that says import turtle. Now that we've imported turtle, okay, we have all the turtle library. The first thing that we want to do is create a new screen on which to draw. And so it looks something like this. Some variable, traditionally it's called S, equals turtle. From the turtle module, run the getScreen function. And this creates a new module, a new window on which you can share things. Okay, I'm not seeing that. Let's see. I'm not seeing that as an option. Let's see. All right. Let's see if we could. We'll have to run some commands, and then we'll have to figure out how to share this. Because this is a new window, it's a new screen, and I may have to do some things to share it with you. Okay, so now we have imported the turtle graphics package. We can start drawing things. We have created a screen on which to draw. We're going to start at the origin at 0, 0. The next thing we have to do is create a turtle. We have to create something with which to draw. And so what we're going to do is we're going to name our turtle Fred, because why not? And so Fred is from the turtle class. He is a turtle. And you absolutely have to spell this correctly or it won't work. So now Fred's a turtle. Now, the simplest thing to do is to tell Fred to crawl forward a certain number of pixels. Okay? And the way we do that is simply our turtle's name, Fred, dot crawl forward 100 pixels. Okay? Now, move this out of the way. Somebody type in chat, is there a screen with a line on it visible now on my screen? All right, do I need to figure out how to share that? Can you see the screen with a line on it? No, okay, let's see if I can figure out how to share that. Okay, now, anybody see that? Can you now see the screen with the line on it in the middle of my screen? Okay, got it. That's what you're supposed to see. So that was created when we told Fred to move forward 100 pixels. Now, we want to tell Fred to turn right 90 degrees. And then go forward another 100 pixels. Okay? So now, when we look at this, we see two lines. Okay? So we have drawn two lines connected at a right angle by telling Fred to move forward 100 pixels, turn right 90 degrees, move forward another 100 pixels. Okay. In answer to Rachel's question, yeah, this is a Pythonic way to do some of the things that you've probably been playing with on computers for quite a while. Now, what we're going to do is we're going to say Fred dot right another 90 degrees, then go forward 100 pixels, then go right another 90 degrees, then go forward another 100 pixels. And now, when we look at our screen, we've drawn a square. So you have drawn a square in Python on a screen simply by telling this turtle to go around. Well, this is boring. It's not filled. Okay, it's not a filled square. It's just, you know, a thin black line surrounding a no-fill white screen. Well, let's make it a little more interesting. Okay. What I'm going to do, and I'm putting all the code up here, and I'll run it again. I want to fill this square. I don't want to draw a plain, empty, unfilled square. I want to make it a blue square. So the way we do that is we say Fred.fillColor blue. Now, when you crawl Fred, begin to fill your object. Then these are the ways to discover it's a smaller square, 50 pixels instead of 100. And then end fill. So now, let's tell Fred to draw this smaller square, but fill it in. When we do that, we see we now have, I did not erase the screen, I just left what was already there because we're not doing anything fancy. We now see we've drawn a blue square. Okay. That's all fine and dandy, but what if I want to draw a circle? Okay. I mean, it could be really hard to figure out, move 1 pixel up, move 1 degree to the right, move another pixel forward, move another degree to the right. It turns out that Python provides a lot of nice things for us to do. So let's say that we're going to say we want to draw an orange circle. Now what we want to do is we want to draw a circle that we're going to fill. And to do that, we simply say, draw a circle whose radius is 100 pixels and end fill. Okay. When we do that, and we now look at our screen, you can see we are now drawing a circle of 100 pixels, a radius of 100 pixels. Starting again, this spot right here is 0, 0. It's the beginning. It's the origin of the XY axis. And so we draw 100. What happens is it keeps track of the fact that you've already drawn some objects on there. And so it moves them in a different direction so you don't completely overdraw everything you've seen. But at any rate, it draws this image and it fills it with orange. It's a circle of radius 100 pixels, and now you can draw things with it. You have other options, and I give you a link to all of the commands. And so what you're going to do for homework 6 is draw some fairly simple graphical images, stars, 5-pointed stars, things like that. And you're going to have to save your file, and you'll run it and save your output and copy that up to GL, and that's what you'll hand in for homework 6. It shouldn't take you more than a couple of hours to do. It's simply an exercise to get you familiar with the simple version of Python graphics, okay? It's simply an exercise to let you play around with the fact that you're not creating triangles with dollar signs and ASCII art. You're doing some fairly simple things that Python provides a library for. So that, like I said, I promised to be out tonight, that is homework 6. And I did want to go over that and get everybody started. With that being done, I want to stop for a minute and I want to go over some of the work in project 3 before I get around to some of the graphics you will draw with PlotDiet. Now, I have put the data files, 14 of them, from April 11th to April 24th, both on Blackboard and on GitHub. I prefer GitHub, but I know from a number of you that you don't like GitHub, you prefer Blackboard. That's fine. I have no problem with that. Let's real quick make double sure that they're there. Sorry. Here we go. Okay, let me stop sharing the screen. Okay. Hold off just a second. Okay. So let's share Google Chrome again. This is what you should see in Blackboard. In the assignments section, where the assignment is project 3, you should see the project description as a PDF and these 14 files. They're from April 11th through April 24th. So if you don't want to get them from GitHub, if you don't like GitHub, that's fine. You can come here to Blackboard. You can go through and download all of these. Okay. Now, once you have downloaded them, you put them in a directory together. Okay. You put them in a directory. Hang on, I'm trying to get PyCharm back up again. Okay, just a second. You put them in a directory together. Call it whatever you want. The reason it doesn't matter what you call it is for your program. When I grade them, I'm just going to change your directory name for the files to what it is on my machine, and it should run perfectly with no problem. Okay, so that is, hang on. Sorry. PyCharm is taking a while to load up again. Okay. Now, let me make sure I'm sharing PyCharm. Okay, here we go. On my computer, I have saved all of these 14 files to this directory. Users, Alfred Arsenal, documents, Spring 21, Project 3, data. That is a name I chose. You choose any name you want, any directory you want. That is the 14 data files. Let me bring up a terminal in PyCharm right now. Let's change to that directory. What's my current directory? PyCharm project. Okay, and let's do an ls, and you can see I just put these 14 projects in this directory. Now, it didn't matter what directory I put them into. I could do anything. It doesn't matter. It's just some place where I can find them. Now, to make it easy on myself, you can see in this code I'm about to start working through that I put the directory name in there. I'm going to declare a constant. And that constant is going to be data directory equals /users, and this is critical I spell it correctly, Now, here in my code, I can just say, this is the directory I'm going to use. All right. So let's look at the files in that directory.
Professor Arsenault, your mic is off.
Yes, let's unmute. That better?
Yep.
Thank you. Sorry about that. All right. So, at any rate, you can see that this is a CSV file. It looks like, you know, a bunch of rows of things separated by commas with new lines at the end and what have you. What we want to do is read in the file row by row and put that in a 2D list. Now, you've already done that. This is similar to what you did in Project 2, but we're going to walk through how to do it. Sorry, I need a new file, which I'm going to call new test.py. And what I want to do is I want to read in one file and put it in a 2D list. Okay, now we have our constant definition. This is our data directory. So I will copy that so I don't lose that constant definition. I am going to need some functions from what's called the OS, or operating system module. So I'm going to import OS. OS lets me do things like change directories, read the files in a directory, list the files in a directory, do whatever. Right now, I want to read in one file. And so what I'm going to do is say first file equals data underscore directory concatenated with slash 04 dash 11 slash 2021. Now, to read that in with open first file, comma, R as in file. The first line, the cat made it hard to see, but if you look at the files, the first line is a header that I want to get rid of. So I just do an in file dot read line. That gets rid of that header file just like you did in Project 2 when you got rid of the first two lines in the student data files. Okay. Now I can do the rest of it. Okay. So I'm going to say data equals in file dot read. This reads in, so this throws away first line. It's a header. This reads rest of file. Now, to create a 1D list, I'm going to split on the new lines. So data list equals data dot split on a new line character, \n. And this creates 1D list, one entry per row. Okay. Now, to make this into a 2D list, I have to split each line. So for I in range length of data list sub I dot or equals data list sub I dot split. This is a CSV file, so we split on a comma. And now what I'm going to do is print data list sub I. Now I should be able to run this without an error. We're going to find out because there probably will be an error too. So let's see. Okay, what did I do? And line 8. No such file. Users Alfred Arsenal I misspelled it. Documents is plural. Let's try that again. Here we go. So this is just like what we did in project 2, right? We read in a file that's a CSV file, and by splitting each line on the new line and by splitting the elements of each line on a comma, we have now produced a 2D list. And so this 2D list contains things, and if you bring this up, it's a CSV file, you could bring it up in Microsoft Excel, you could bring it up in Apple Numbers, you could bring it up in Google Sheets, okay? You can see what it looks like, and I'll do that. Let me go to Chrome. Let me open Google Sheets. These are the old things. Let's see. Just make sure I can open the thing. Open file picker. I want to upload. I know where it is. Here we go. We'll just pick the 15th at random. So opening Google Sheets, you can see what it is. Now, this is the header line that we threw away. It's got province or state, country, region, last update, lat long, confirmed COVID cases, number of COVID deaths, recovered, active, a FIPS code, an incident rate, how many cases of COVID per, I believe it's 100,000 people, the total number of test results they have, the number of people currently in the hospital, the fatality rate, what percentage of people who get COVID die, particular codes that we don't care about, how many tests have been done for 100,000 people, and so on. This is what the file looks like if you open it in Google Sheets. If you open it in PyCharm and do the separation like this, this is what it should look like, okay? So this will read one file. Now, the only problem is, well, there are two problems. The first problem is we need to append to each line in here the date, because we're going to do graphics based on date, based on trends over the 2-week period where we recovered data. So we need to append to each line the date. Now, for the heck of it, I said this file is the 11th. So what I now need to do is I'm going to say data list sub I dot append 11, the date. This is the simplest way to do it, and I'm going to show you how to make that more general in a minute. But let's run this code. Hopefully I haven't messed anything up by doing that, and you can see that I've appended an 11 on each one. Why is that important? Because I'm going to append the date on each one. Why is it important to append the date to each row of data? because I'm going to do graphs, I'm going to do analysis that shows, for example, Alabama, the number of cases on the 11th, the 12th, the 13th, the 14th, the 15th, the 16th, and so on, so that I can draw a trend line. I can draw a chart with the trend line. So I need to include the date, and the date was not included with each row in the file. So by doing this, I have now inserted into each row the date. Okay, so far all I've done is a small re-implementation of Project 2. I read in the CSV file and I created a 2D list. What do we have to do? Well, now we have to read in all 14 of these files. And we're going to need to combine them into a single list. We're going to need to create a single database of these files. So let's talk about how we did it. And this is why it's important for you when you when you download the files. Okay, sorry. Okay, let's go to your question set. How do you create a directory? Okay, when you download a file, in general, it goes into your downloads directory. Let me share my screen, which is always risky because who knows what's on this stupid thing. Okay, when you download your file, okay, in general, both on Windows and Mac, unless you tell it otherwise, it goes into this directory called downloads. So you can see that these are all the files I have downloaded to my Mac recently. Windows is very similar, but this is the Mac. So in theory, I'm sharing my screen and you can see the Finder window that pops up that says, this is the contents of my downloads directory. And you can see, for example, that I downloaded the video of last Wednesday's lecture and the automatic transcript that WebEx created of it. And I downloaded the video of last Monday's lecture and the transcript. And I downloaded a PDF of my lecture notes on importing Python code and some other things. Okay, you can see what I've downloaded. By default, this is where things you download go. So then what you do is to create a new directory. And again, this is similar on Windows. This is Mac. To create a new directory, you go up to File and you say New Folder. And now it gives you an untitled folder and where you want and what you want to call it. And so this is where I would say something like Project 3 Data. And then what I do is it's a simple matter of copy and paste or cut and paste. All the files I downloaded, I just move into that directory. And when I'm done, that's how I have all the files. Okay, so that was how I created the directory. Now, when you download, if you want, you have an opportunity to specify the directory. If you could specify the directory you created ahead of time, and okay, let's see, I'm gonna stop sharing the screen. And hopefully I'm going to go back to sharing PyCharm. And I'm going to go back to sharing Google Chrome. So did that answer the question on how to create a directory? Where's the chat window? Okay. Did that answer the question on how to create this directory and where to put your how to put your files in? That's Mac. Windows is very similar. When you download these files, they go to a place. If you don't tell them where, anywhere else in particular, they by default go to your downloads directory, and then you just round them up and it's copy and paste into the directory you want, and then you're done. Okay. All right. So everybody good? I mean, ask questions now. This lecture is for you to understand Project 3. So this part of this lecture anyways, for you to understand Project 3. So ask more questions if you got it. Now,
I have a question.
sure, go ahead.
Could you explain a little bit how to use Plot9? Because I'm at the point in the project where I have the data imported in from the pandas program.
Right.
And I don't know how to use Plot9 here. Let me pull up the project real quick. Just like a little bit of an explanation on Plot9 would be nice.
I tell you what, if you don't mind, since it's 25 till 5 and I've got 40 minutes, I want to cover one more thing, and then I promise I've got a bunch of examples and a bunch of graphs for Plot9. If you can hold on just a bit, is that okay?
Yeah, that's good.
Okay. What I wanted to do is make sure students understand what I've shown you right here is how to read in the data from one file. You need to read in the data from all the files in that directory and append them into one list. So basically what you're going to do is you're going to create a loop and run all this into a loop. Now, rather than try to do this live and botch it, here is the code I've already written that does it. Okay. I imported OS. I created a master list, which is going to be my database, which is just an empty list. What I'm going to do is I'm going to read in each file. As I read in the file, I'm going to do what I did in the previous thing and create a list, a 2D list. When I'm done, I'm just going to append that 2D list to this. And so everything from all 14 files is going in here. Now, I think in the write-up, I called this database or something like this. It doesn't matter what you name your variable. Pick your poison. You know, like I said, I think I called it database. It doesn't matter. What this does is it's a command from the operating system that does a change directory. This does a CD and says, put me in this directory where I'm going to read from. Now, what os.listdir does is it creates a list of all the files in the directory. So that's why I needed to import OS. os.listdir gives me a list of every file in the directory. Now I can run a for loop, right? For each file in this directory, here's what I'm going to do. I had a print statement that prints the file name, right? Remember, this is just printing the file name so I could check it. Now, as I originally downloaded data, I got some cruft. I got some extra stuff. Some stuff was added that wasn't the CSV file. If you know your directory is pure, if you know you've got nothing but the data files in here, then you don't need this. But as a safety, what I do is I check and see if this is a .csv file. I check and see, is this one of the 14 data files that I needed? And I do that by saying if .csv is in the file name. This just checks to see if these 4 characters in order are in this string, which is a file name. Okay, file, remember, is a string. It's the file name. And if it's got .csv, we want it. And if for some reason it doesn't have .csv, it's an extraneous file that wound up in the directory, we're going to have to go figure out how to delete it. But for now, we're just not going to read it. Okay, so that's what this does. Now it's just the same. Open the file as in file, read the first line and throw it away. Now read the rest of the file. Split on new lines. And then for each line in here, split on commas. This creates the 2D list. And then this adds them to the same master. And so when I'm done, so now we're going to try to run this. And if this is done, what will happen? You're going to have to take my word for it, but if you go up here, what this has done is it has read in all 14 files. And so now I have 14 files worth of data all in a single 2D list. And so now I can move on with the rest of my analysis. So to read in all 14 files, and combine them into a single list, you do something like this. Now, this does not have the date appended, so you have to figure out how to append the date to each line. But you can do that fairly simply, right? You just track what date it is, what the date of the file you read in, and append that, and now you can move on. Now, in the assignment, what I then have you do, you can see if I went back to Google Sheets, right, you have all these extra columns that nobody cares about. I frankly do not care what the latitude and longitude of the center point of Alaska is, or Arizona, or anything else. I mean, nothing personal, but I really don't. It's a COVID case trend line. I don't care, what the center point is. So what I have you do then is create another 2D list where you pick certain columns. Okay, you pick the state name. They're all in the US. That's a don't care. The last update is not really related to the date. It's actually the day after the date. We don't care. Skip the lat, skip the long. Keep this column, which is the confirmed number. Keep this column with the depth. So the next part of the homework assignment is to take that big honking database, that big honking thing you got here that's a 2D list with data from all 14 files, and narrow it down to the columns you care about. Throw out lat, long, and all that other stuff. Then you've got that. Now you can move on to the question that was just asked. I think that was Ian asked the question. So let me answer that directly. Now, pandas is important because you have to convert your 2D list into what's called the data frame. That's straightforward. If you have questions about that, ask later. But once you created it into a data frame, now you have to use plot9. So let me get to the rest of the lecture since I still got half an hour. I'm going to work through the lecture, and then we can talk about some specific examples if you're having an issue with the specific homework. So here we go. Where this came from is actually called the language R. The language R was created to do statistical analysis on big data. It followed a language called S. There was a language called S that was used for statistical analysis of big honking plots of data. The follow-on to S was R, which is actually before S, so I don't know why, but somebody thought it was clever and they did it. R has a package called ggplot. GG stands for Grammar of Graphics, and a guy named Hadley Wickham, who is absolutely brilliant, came up with this whole idea of a toolkit to build bar charts and column charts and all the fancy stuff you could ever possibly want using this particular library, and it became very popular in R. Well, if you get into the data science arena, you will find that all your programming is either done in Python or R. And the statistics geeks, I am one of those. I have a master's in statistics along with the one in data science, like R better. But the computer scientists like Python better because R is more optimized toward fast data processing. Python is a more general, useful computer programming language. I like it. And so Python had to come up with its own version of ggplot, and that's called plot9. So plot9 is a library package that creates graphics. It's modeled after R's ggplot. And it's weird syntax, and I will acknowledge its syntax is very weird, and we're going to go through that. Its weird syntax is because it has to fit this idea of a grammar of graphics. It has to use graphical language. Okay. Any plot9 object, you use code to build the object, and then when you execute it, Jupyter or whatever else you're running this in will draw the graphic for you. Just like the turtle graphic, you drew the graphic by telling the turtle, go here, fill with this color, use this colored pen, what have you. In plot9, you say, draw this kind of chart, and here's how I want you to do it. So you will always have the term ggplot. Remember, that stood from the Grammar of Graphics plotting from R. And that creates an object. So this gets back to classes and objects, that we're doing a little bit of that. You build an object. The next thing in your grammar, the next thing in your statement will be an aesthetic. And so you will see the letters AES. AES is short for aesthetic, and that means it looks like this. So I'm going to build a graphic. I'm going to build a plot. It's going to have this aesthetic. It's going to look like this. Now, in most things we'll be doing in this class, you're going to draw things in a two-dimensional Cartesian plane, X and Y axes. And so what you're going to provide are labels for the x-axis and labels for the y-axis. You're going to tell Plot9 which variables to use and how to label them. And you're going to tell Plot9 what colors to use for the points that it's going to plot. You're going to tell it to use green and blue and red and what have you. These are the aesthetics. So you're going to say, I'm going to create a graphical object, ggplot. And it's going to look like this. It's going to have this aesthetic. This is what you're going to call the x-axis. This is what you're going to call the y-axis. And this is the color you're going to use. The last thing you have to do is tell Plot9 what kind of plot, what kind of graphic do you want? Do you want a scatter plot? Just draw the points. Just plot the points on the XY axis, and I will decide from looking at it whether these points make sense, whether these points have a trend, whether these points tell me something, or whether this is useful. So points, and I'll show you some examples in a minute, points will just produce a scatter plot. It will produce a graphic that has points all over XY that you can see and decide for your choice. You can draw a bar chart, which is called a column, and you're going to see geom_col, and that's what it's going to draw things, and we'll show an example of that. You can draw stacked bar charts, you can draw histograms, you can draw whatever. We're going to go into an example. And then if you need to transform the data before you plot it, if you need to convert anything to a logarithm, if you need to convert it to an exponent, if you need to shift things over, whatever, you do that. You put these all together, and this creates the one statement that you need to produce a bar chart in Plot9. And so here is an example, and I'm going to try to blow this up because this is hideous to use. Okay, so what was done in this case, if you go to the point, the website where I told you the Plot9 documentation is, all of these examples are given there and with some additional supporting text. So if you're curious or if you want more information, you can read all of that. So at any rate, we import what we need from Plot9. The Plot9.data just says, I'm going to use a pre-canned data set. I'm not going to use my own data in this example. You will not need the from Plot9 data.import because you're using your own data. You're not using theirs. You will need the Plot9 import, and you will have to see what you want. Now, these are point charts or start as scatter plots. So as I said on the last slide, we start with, sorry, I forgot when I'm in presentation mode, I can't click on it. We start with ggplot. This says, hey, we are producing a graphic. We are using Plot9 to produce a ggplot object. Okay. Then don't worry about MT cars. That just says the data set. You won't need the data set for here. So ignore this. Remember I said now you have to have an aesthetic, AES. Okay. This aesthetic, so ggplot aesthetic, it looks like this. Now, you can say x equals this and y equals that. Or if you leave out x equals this and y equals that, the way Plot9 interprets it is the first thing is the label for the x-axis, and the second thing is the label for the y-axis. So remember, an aesthetic says this is what you call x, this is what you call y, and these are the colors to use. So what this says is use weight, WT, weight, for the x-axis, use MPG, miles per gallon, for the y-axis. Again, you could say x equals WT, y equals MPG. If you leave that out, plot9 says, oh, this is X, this is Y, we're good. Then you say, these are colors to use, okay? And plot9 has a variety of default colors that it uses in order. You say assign different colors based on whatever the value of gear is, okay? Now, then you have to say plus geom point. I don't want a bar chart. I don't want a histogram. I don't want a whatever. I want a scatter plot. I want geom point, okay? Now, the rest is the statistical transform that you're going to do. This says smooth it out using log, and this says facet rep. You don't need to do these. These are more than you need for project 3. You don't need the fancy things. You would just say ggplot aesthetic x equals this, y equals that. These are the colors to use, and I want a scattered plot, so I use geom point. And so what it does is it tells you that I broke it up. 3-speed cars are here, 4-speed cars are here, 5-speed cars are here, and here is a scatter plot that says, here are all the data points. Weight in thousands of pounds and miles per gallon by EPA rating. And these are where the cars are, okay? And then this stat smooth and facet wrap are what tells it to draw. It's a linear regression. It basically says these are the trend lines. You don't need to add them. If you had left this plus stat smooth out, you would not get this trend line. You would just get the points, which is fine. This is a scatter plot. So this is how to use plot9 to do a scatter plot. ggplot. I'm drawing a plot. Aesthetic. This is what it looks like. This is what I'm calling the x-axis. This is what I'm calling the y-axis. And this is what I want to use to differentiate my values by color. So that is how you would draw a bar chart. Again, this was done with a pre-canned set of data on cars that plot9 distributes as an example for you to play with. We won't worry about that. Here is a bar chart. Okay, so up above, what they've got is a 2D list. This is a 2D list that's been turned into a data frame that tells you the data they're plotting. It gives you 5 rows. They're plotting way more than 5 rows, but this is what the 2D list looks like. It's got a manufacturer, it's got a model name, an Audi A4, what its engine displaces, 1.8 liters. This is a 1999 4-cylinder automatic transmission. Don't remember what the other thing is. It's a compact car. And when you look at this entire table, you say ggplot from MPG. Now it defaults, or I'm going to explain something in a second. Plus, I want a bar chart. Now you can use geom bar. I told you in the written instructions for this one, in the project3.pdf, you will discover, hopefully the easy way, don't use geom bar, use geom call. They both provide, both geom bar and geom call provide these bar charts. I think geom call is a whole lot easier to use, so that's why I told you to use it. You can use geom bar, but it gets messy. Okay, but you say then geom bar or call. And then aesthetic, X equals class. And so what PyCharm did is it says for class here, compact, there are 2-seaters, compacts, mid-sizes, minivans, pickups, subcompacts, and SUVs. Now, I did not tell, or this is an example, the writer did not tell plot9 what to use as the y-axis. And so the only thing plot9 can figure out to use as the y-axis, it does automatically, is the count, how many of them. If you don't tell it what to use in the y-axis, it's going to tell you how many values there are. How many compacts, how many 2-seaters, how many minivans, how many pickups. So this is a bar chart that tells you how many cars are in the SUV class, how many cars are the subcompact. Again, you don't have to use geom bar. I find geom call gives you better results. But the syntax of the command is going to be almost identical to this. ggplot, data set, I want a bar chart, I want the x-axis to be called class. Remember, I could have left out x equals and just written class. It would work. It defaults that way. And then you get this chart. This is a different kind of bar chart. This is called a stacked bar chart with different colors. It comes from the same database, miles per gallon database. The aesthetic x equals class. What this fill does is says this is how you tell it what colors to use to break down the different types of cars. So what this means is, example, Plot9 generates these keys, and it says drive. Well, there are four-wheel drive cars, there are front-wheel drive cars, and there are rear wheel drive cars. Okay, and so this is my aesthetic. I want a plot. I want it to be a bar chart. My aesthetic is I want the x-axis to be class. I don't tell you what the y-axis is, so the y-axis is automatically going to be count, the number in each one. And then this is how I play around with the color scheme in each one. I say I want it to break down colors by whether it's rear wheel drive, front wheel drive, or four-wheel drive. And so you can see that in SUVs, everything is either rear wheel or four wheel. There are no front wheel drive SUVs. Okay. Two-seaters, there are only rear wheel drive. That's it. Which makes sense. Why would you have a four-wheel drive, two-seat sports car? Wouldn't make sense. Okay, so this is how you would create a bar chart. If you want it sideways, ggplot from MPG, I want a bar chart, coordinate underscore flip. Coord underscore flip says flip the X and Y axis. Instead of drawing a histogram, a bar chart that goes up, draw a bar chart that goes to the right, starts to the left and goes to the right. This is just a variant of the other one where I have flipped, coordinate, flip. Theme classic is just something that tells Plot9 use your basic defaults. You could have left that out and it would have worked the same. Okay. This is a bar chart, a column chart, where we flip the X and Y axis by telling it to flip the coordinates. Okay, so if you like the straight up and down, that's fine. If you like the sideways, you just do a coordinate flip, and this is all drawn for you. Okay. If you truly are a Game of Thrones geek, you can create a map using ggplot, and I won't go into detail. But there is actually a thing called geom underscore map. Okay. Geom underscore map uses a built-in library of geographic information systems data. It has access to most of the United States and most of the world with the countries up to date, and a few fantasy worlds as well. And you can see that it has Westeros, and it has the islands, and it has, you're going to make it a political map rather than a topographical map or a hydro map. You're going to draw the wall, which is up here, the wall separating the north, the wildlings from Westeros. And basically, just with that text, you can draw a fairly reasonable map of Westeros and the Game of Thrones lands, and you can see who owned which one. Okay. And if you're big into chemistry and chemical engineers, they actually give an example of here of how to draw the periodic table. If you have the periodic table represented in a 2D list, a data frame, then what you do is you can start with a geom tile. A geom tile is something that looks like a tiled display. And you can start building them with height and weight and get the right basic structure. And then you can flip it over. You start with this. This is the periodic table upside down. These are the rare earths and the man-made elements. These are the basic beginning ones. Hydrogen's over here. Helium's over here. And so now you flip it over. And you say, this is the top and this is the bottom. and here are your aesthetics, and this is what you want. Okay. And so you start there, and now to make it more interesting, you can add colors to fill. You can mark the metals in one color. You can map your halogens in another color. You can do metalloids. You can put your noble inert gases like helium and argon and xenon, etc., down here in this color. You can put non-metals, transitions as the man-made elements, the rare earths, which they call halogens, and so on down there. And then you can start labeling each one. And so you can put the element name along with the chart in there. And then you can go as big, as detailed as you want. You can start adding text that includes the full name, the element number, the full name, the atomic weight, the atomic number, and have you. And by the time you're done with all of this, with Plot9, you will have yourself a really nice periodic table that you coded by yourself in Python using this imported code library. And so then you can do all the other stuff. You can talk about what year it does, whatever. This is just a case of really getting into the toolkit. Getting back to Ian's question, I think it was Ian who asked the question of how we got started on this. So how do you use Plot9 to draw your graph? Okay, after you have used pandas, you now have your 2D list converted into what's called a data frame. It has to be a data frame so that Plot9 will recognize it. So when you're ready to draw your list, you basically use, and I gave you, let me real quick see if I can find the PDF. There it is. I think I gave you a little bit of what it's going to look like, okay? Now, what you're going to do is you're going to say ggplot, then I'll give you geomcall with an aesthetic. On the x-axis, I want you to use state, and on the y-axis, I want you to use confirm. Now, I didn't give you the full syntax. I left out that ggplot object. But what you're going to do to this is you're going to say ggplot plus geomcall, x equals state, y equals confirm, and you're going to feed your data into that. And you should get a bar chart. You know, a column chart is very similar to a bar chart. And if you want to play around and you decide you want the geom bar, say that's why. So step 11, you're saying ggplot data frame plus geom-call aesthetic, x equals this, y equals that. And that will give you a bar chart like we just showed. Trend line, okay, is going to be basically a plot. Was like the first example we covered. You're going to say geom-point, and you're going to pick, well, first of all, you just got to pick these states, and then you're going to say ggplot from your data. You're going to pick geom-point, and then if you do that data smoothing, it will give you that trend line. Or if you don't want that out, you just want the plot in there, you can do a geom-line, and that will give you the line of the data through there. Okay, so does that help you get started on that? Okay. In answer to the question, yes, everything is .csv. All the file input are .csv, nothing different. Okay. All right. So that should get you started. We are going to talk more about this on Wednesday. In Wednesday's lecture, we're going to talk about analysis of algorithms and all those searching and sorting algorithms that we talked about last Wednesday. We're going to talk about how they work and which is faster and how to decide and everything else. But I didn't want to do that today because I wanted to spend today talking about the project and the homework and give you some examples. So again, really by Wednesday, by this Wednesday the 5th, you should be able to create, to read in these 14 CSV files and create this database of all the data that you need to do the data. By this Wednesday the 5th, it's okay if you don't have the Plot9 stuff that we've talked about working yet. That's okay. I mean, if you've done it already, cool. But if you don't have that working yet, that's fine. We'll talk about it again on Wednesday, right? You don't have to have this project in for another 9 days from now. But you really should, by Wednesday the 5th, be able to read in all 14 of those files and put them in your 2D list that is your database, your master list, your data set, your database, whatever you call your variable. I don't care, as long as it's a reasonable variable name. That should be good to go by Wednesday. Okay. Because if it's not, you're going to be in a big crunch next week. And let's try to avoid that, because this Jupyter notebook, importing pandas, importing plot9, and I am going to warn you, we're going to talk about plot9 again on Wednesday, because that's where a lot of people are going to have a lot of problems, because it's a little different from what you've done before. It's okay. We're teaching you a new skill. We'll go through it. All right. So with that, I have, according to my watch, 7 minutes left, but I'm going to go ahead and call the lecture over, because I got to get homework 6 listed with the turtle graphics and tell you what you got to do specifically. It's an easy one. You just have to draw a couple of simple shapes. It's not a big deal, but it's 50 points, so you got to do it. Project 3, like I said, by Wednesday, please be able to do your, have your big honking 2D list with your data set in it. If you're not there by Wednesday, you got to let me know so we can help you get over that hump. Okay. Any more questions before we wrap up today? Okay. I will see you on Wednesday then. I will get the, you'll see an announcement on Blackboard when the homework 6 is out. Talk to you later.